Welcome to Felimates Academy. I'm Felicitas Chenge. Today we are going to solve that system of equations that I've put up there. Right. To solve that using Gauss Jordan elimination, first we have to write this system of equations. In augmented matrix form. So we are going to write this as an augmented matrix. So we are going to write out the coefficients only. Coefficient of x is 1, coefficient of y 1, then constants this other side 5, 2, 3, 5, 8. For coefficient of y, we don't have an element, we don't have a term in y there, so it's 0, 5, 2. Right, to solve this, we have to reduce this matrix to a reduced one, which will be 1, 1, 1, and these are going to be zeros there. So to reduce to this form, and we are going to have constants there. So to reduce that to a reduced row echelon form, we are going to perform row operations. So we are going to perform row operations on row 2, since we have a leading one there. Remember, those ones are going to be our pivots. So to reduce that 2 to a 0, we are going to use our pivot. This one will be our pivot for this column. This 3 is going to be our pivot for this column, and this 5 is going to be our pivot for that column. So we are going to reduce this 2 to a 0. So we have 1, 1, 1, 5, 4, 0, 5, 2. We are going to perform our row operations on row 2. So row 2 follows, we are going to multiply this pivot by 2 and subtract row 2 from row 1. So it's 2 row 1 minus row 2. 2 minus 2, we have multiplied 2 by 1, it's 2 minus 2, 0, 2 minus 3, minus 1, 2 minus 5, minus 3, 10 minus 8, 2. Right. We want to reduce this 4 to a 0. So to reduce that 4 to a 0, we have 1, 1, 1, 5, 0, minus 1, minus 3, 2. Row 3 will follow. So row 3 follows, we multiply this row 1 by 4 and subtract row 3 from the result. So it's 4 row 1 minus row 3. So 4 by 1 minus 4, 0. 4 by 1 minus 0, 4. 4 by 1 minus 5 minus 1. It's 4 minus 5, we have minus 1. Then 4 by 5, 20, minus 2, it's 18. Right? We are now moving on to the second column. We want to reduce this 4 to a 0. We are going to have 1, 1, 1, 5, 0, minus 1, minus 3, 2. This is going to be our pivot. So we are going to multiply this by 4 and add it to that. So row 3 follows 4 row 2 plus row 3. So 4 times 0 plus 0, 0. 4 times minus 1 is minus 4 plus 4, 0. 4 times minus 3 is minus 12, plus minus 1 is minus 13. 4 times 2, 8, plus 18, 26. Right. We are now moving on to this minus 3. We want to reduce that minus 3 to a 0. Remember, our pivot is minus 13 this time. So, we are going to have 1, 1, 1, 5, 0, 0, minus 13, 26. Right, to reduce that, we are going to multiply row 2 follows 13, row 2, minus 3, row 3. Right. So we are going to multiply 0 by 13 minus 3 by 0, it's 0. 13 by minus 1, it's minus 13, minus 0, minus 13. Then it's a 0. 13 by 2 is 26, minus 3 by 26. So it's 26 minus, so it's minus 52. Right. I'm going to erase this part. We are now moving on to this. This should reduce to a 0. So we have 0 minus 13, 0 minus 52, 0, 0 minus 13, 26. Right. For this to be a 0, we are going to multiply this by 13. So row 1 follows 13, row 1 plus row 3. 13 by 1 is 13 minus 0 becomes 13. 13 by 1, 13 minus 0, 13. 13 by 5, 65. 65 minus 3 by 26. So 13 by 5 is 65 plus row 3, 26. This becomes 91. Right. Then this becomes a 0 there. Since we are multiplying 13 by 1 minus 13 is a 0 there. Right. We are going to reduce this to a 0. Our pivot is minus 13. So we have 0 minus 13, 0 minus 52, 0, 0 minus 13, 26. Right, to reduce that, remember our pivot is minus 13. So we are going to add row 1 to row 2. So row 1 follows row 1 plus row 2. So 13 plus 0 is 13. 13 plus minus 13, 0. 0 plus 0, 0. 91 minus 52 is 39. Right. Then remember these should be ones. So to reduce those to ones, we are going to row 1 follows 1 over 13 times row 1. So 1 over 13 times 13 is 1 times 0 times 0. 1 over 13 times 39, 3. For second row there, it's row 2 follows minus 1 over 13 row 2. So by that 0, 1, 0, minus 1 over 13 times this, it's 4. Then row 3 follows minus 1 over 13 row 3. So it's 0, 0, 1, minus 2. So remember this is x, y, z. So our x is equal to 3, our y is equal to 4, and z is equal to minus 2. That's our solution for that system of equation using Gauss Jordan Elimination Method. Thank you.